Hello, everybody. Let me make sure that my sound is on. Oh, maybe it's actually on. Well, happy Monday to everyone. Welcome to Ask Math Anything. This is a show about anything, as long as the anything is something about math. It also appears to be a show about the color of my shirt for some odd reason. But now, if you're new to this, what I'm going to tell you is that this is not going to be like the math class that you used to be taking at school. I understand that many people might be out of school now. Hooray! Or is it hooray? Maybe it just means that we now have some time that we can use to go and learn something else. And we're going to try to do this live stream in a way where all of the topics that we talk about are the topics that maybe are they're the mathematical topics that you're interested in. If you're new here, please feel free to ask any kinds of questions that are about math, and I'll go and try to make up a explanation for you on the spot. And the purpose of this is so that you can kind of learn about the different things that you might be curious about. If you've been here before, you know we're probably going to talk about topics that are understandable to people who are learning algebra or geometry, because that's what most of the people taking this live stream are taking or have just taken in school. All right. Now, what should we talk about today, besides the fact that my shirt seems to be about the same color as a banana? Let's see what math questions we have today. So I see that some people are actually talking about the math classes that they're taking. Somebody's taking pre-algebra. Welcome. We're always going to try to choose to answer questions in a way that even if you're taking pre-algebra, if you just are patient and try to understand what's going on here, it might also make sense to you. I'm looking to see what kind of question we'll start with today. I see that somebody has asked me, what is 2 to the 2 to the 2 to the 2 to the 2 with 5 2's? So if you're asking me what is 2 caret 2 caret 2 caret 2 caret 2? Now here's a question. What goes first? What's the order of operations? The question, yes, we did do this before. Thank you very much. Someone has a good memory. So let's just quickly remind, because I remember I asked somebody to please type this in. It turns out that if you do this, the way that you do the order of operations is actually you do this one first. You actually do this part first. That's nothing. That's just 4. Then you do this. 2 to the 4 is only 16. Oh no! 2 to the 16 is 65536. And this is equal to, oh no. That's the best thing I can say. It's 2 to the power of 65,536. It's about a 20,000 digit number. Not too much fun. But, you know, it exists. Wolfram Alpha could figure that out. And indeed, somebody did comment, we did this question before, so let's not go deeper into this now. And of course, you can now get a sense that if you decide to watch our live stream, you'll get to see a tour through all kinds of different things in mathematics. All right. What else can we do here? More questions. Wow. Some people are asking me strange questions about number theory. And I did see that there are people here who are just taking pre-algebra. So I want to make sure that whatever we're talking about is something that, you know, as many people can understand as possible. Somebody has asked, show that if p is a prime bigger than 3. I mean, I'm just going to write down the question to do justice to the question, but we might not solve it because solving it might be too deep for what we're doing in this live stream. What you're saying is, you're making a statement. It's that every prime p, which happens to be bigger than 3 is different. For every prime p which is bigger than 3, what's going on is that you can't have both 2p plus 1 and 4p plus 1 prime simultaneously. So this is an interesting fact. If I'm looking at this particular fact, it's like, gee, how would you go about and try to prove something like this? I'll at least like play with it a little bit. If I play with it a little bit, and if I am not successful, then we'll say, well, this is probably too hard. But what you're saying basically is that it's not possible for p, 2p plus 1, and 4p plus 1 to all be primes simultaneously. Let's be a little bit more clear. You're saying that there's a prime here, and here's another number, and here's another number. You're saying that you can't have all 3 of these primes simultaneously. I have no guarantee I'm going to solve this question for you, okay? But I'm going to tell you that my immediate instinct is that 3 seems to be kind of important. There are 3 numbers here, and mysteriously there's this 3 over there. So it looks like you're excluding just on purpose something about 3. This makes me want to think about what happens if I look at the remainders when I divide these numbers by 3. I'm not guaranteeing you that I'll be able to solve this problem. In fact, it might be a disaster. But I'm just going to say that if I've got these numbers, I wonder if I should think about what happens if I look at the remainder when I divide p by 3. If you're taking pre-algebra, don't worry. I'm not using anything super fancy. I'm just answering questions I'm just thinking about this from the perspective of divisibility. And you said 3 and 2 work. That's why we said for every prime p which is bigger than 3, you want me to show this stuff, right? So there's something a little bit funny about this number 3. And I'm just a little curious. I'm going to say, look, if I have a prime which is bigger than 3, then that prime's remainder when I divide by 3 is either 1 or 2. Okay, there's a very important fact that comes straight from here. When you take p divided by 3, you get a remainder which is 1 or 2. Now that's a very important place where I've used the fact that the prime is bigger than 3. Because if the prime was 3 itself and you divide it by 3, you get a remainder of 0. Now why is that interesting? I've got 2 cases. I'm curious if anything nice happens. Case 1. P divided by 3 gives remainder of 1. Okay? If p divided by 3 gives a remainder of 1, can you tell me anything about what happens when I take 2 times p plus 1 and I look at its remainder when I divide by 3? We're actually doing number theory now, but it's not crazy number theory. P divided by 3 giving you a remainder of 1 means that, that means that p, so p is equal to a multiple of 3 and then plus 1. Right? That's what that would mean if when I divide by 3 I get a remainder of 1. So if that's the case, you know what happens when you take 2p plus 1? 2p is equal to 2 times a multiple of 3. That's still a multiple of 3. And it's plus 2. Is everyone with me here? I just did double of this. A multiple of 3 times 2 is still a multiple of 3, but the 1 times 2 is 2. Okay, so in that case, what's 2p plus 1? Oh, look, if I do 2p plus 1, I get a multiple of 3 plus 3. So 2p plus 1 is equal to a multiple of 3 plus 3. Guess what? That's definitely not prime. That's a multiple of 3, right? Multiple of 3 plus another 3? That's not prime. So I'm supposed to prove that I can't have both these two prime simultaneously. I've just shown that if p divided by 3 gives a remainder of 1, then 2p plus 1, that's not prime. Okay? So then this thing is not prime. I'll write an exclamation mark because I'm excited. That's exactly what I needed. Okay? So I've got the other case. Case 2. Case 2 is that p divided by 3 gives a remainder of 2. Could this be useful? Well, what's going to happen if I take 4 times p plus 1? I'm getting excited. I think this is going to be good. So if I take p divided by 3, if it's a remainder of 2, that means p is a multiple of 3 plus 2, right? So that means p is equal to multiple of 3 and then plus 2. Aha. Now you know what's going to happen when I multiply. Oh, you said, or it's a multiple of 3 minus 1. You could write it in either way. Both of them work. Like both ways of thinking about it are okay, right? A multiple of 3 plus 2, multiple of 3 minus 1. Those are both the same. Like, it's just a different multiple of the 3. But now let's go and multiply by 4. It's 4p plus 1, right? So if I take 4p plus 1, I'll skip a step. 4p plus 1 is going to be multiple of 3 multiplied by 4 is still a multiple of 3. Multiple of 3 plus how much? Well, it used to be 2. 4p plus 1 is going to be 4 times 2, which is 8, plus a 1, which is 9. Now, who else is excited? Why is this good? Multiple of 3 plus 9. So that means that this is going to be a multiple of 3. It's not prime. That's not prime, right? Because this thing is a multiple of 3, not prime. Hey, we're done. That's what we needed to do. We just found out that if I had a prime p, which is bigger than 3, then either the 2p plus 1, either the 2p plus 1, or the 4p plus 1 is not prime. And that's it. Okay, I'm actually surprised that we managed to solve this, because these kinds of questions are things that are generally sometimes hard, because there are proofs. I see that you say it's easy. To be honest, when I started this, I wasn't sure it would be easy, because there are a lot of problems in number theory which look really easy and are insanely hard. It's like if you asked me, can you prove that there are infinitely many pairs of primes, like 11 and 13, where they differ by just 2? What an easy problem. You know, it keeps happening. Like, you know, what are some other 2 primes that are real close together? Like 101 and 103, you know, that just keeps happening. How easy could it be? This must be a really easy problem to just go and say infinitely many times you have prime next to prime with just a difference of 2. The only problem is that nobody in the entire world knows how to prove that. So when you gave me this, I was also scared. Because if you give me this, I'm like, is this one of these crazy hard problems that no human being knows how to solve? But once I wrote it down, if you saw the way that I thought through this, the way I thought through this was, it looks mightily suspicious. There are 3 numbers, and there's a 3 over there. And why did you exclude 3? You know, of all the primes to rule out, why are you ruling out 3? Usually people just rule out 2, because you know, there's one really weird prime called 2. All primes are odd, except for 2. So 2 is just weird. But if you're going to rule out 3 as a prime, then you must be using 3 somewhere. And so that's actually how that's how I thought of this. I was like, if you're intentionally ruling out 3, I bet that the reason you're ruling out 3 is because 3 is the only prime which has a remainder of 0 when you divide by 3. And since there are 3 numbers to play with, I was like, I bet I can try to show that one of these 3 numbers is a multiple of 3. And I guess that's what happened. Okay, can we have some easier problems, please? By the way, we had a person here who said they were learning pre-algebra. I hope that this made some sense to you. And by the way, if this makes sense to you, you have just learned number theory. Okay, more questions. Wow, I see that I have multiple people who are asking for like some ways to prepare for or do well in math competitions. I'll give you a quick answer to this because we talk a lot about this like on the weekend show. The best way to prepare for and do well in math contests is to try to challenge yourself with things like this, where it's like you don't quite know what to do. I mean, not for you, not necessarily this question, but like for me, why I took this problem from you is I looked at it and I said, I actually don't know how to do it. And as I was writing it down, I was prepared to tell you guys, I'm going to think about it for a while and we're just going to get stuck. I was prepared to go through this and get stuck at the end. But that's the same attitude you should take when you're preparing for math contests. Go and try some questions that are just on the periphery, on the boundary of what you can do. And as you keep doing that, you'll just get better. And pretty soon you just won't be scared of anything. So that's the advice. And if you're looking for more questions, go look for the old questions that happened previously in that contest. And then like look at the solutions for hints when you need them. Let's talk about some math problems. Now, this is an interesting math problem. Not really a math problem. Jeffrey Zhang asks, if you dig a deep hole from the North Pole, will you reach the South Pole? It's a pretty interesting idea. All right, so this is a classic idea of, this is the Earth. Let's pretend that we fix the rotation of the Earth. You know what? The Earth, this is a live stream where I care about accuracy too. As some of you may know, the Earth is actually tilted on an axis. All right, so that's the Earth. But so if this is the Earth, you have your great North Pole over here. This is the North Pole. And the South Pole, it's on the other side of the sphere. This is the South Pole. By the way, the reason why the South Pole is not just this point here is similar to why the North Pole is not just like that point there. I'm imagining that the sphere has the thing kind of sticking up, okay? So now, what people are saying is, let's go dig a hole. You want to dig a hole from the North Pole, and you want to dig all the way to the South Pole. Let me tell you why this process won't work. First of all, there are multiple ways that this won't work. One way that this won't work is, you know what you will achieve if you dig from the North Pole down, you know, like about 100 miles? If you dig down like 100 miles from the North Pole, congratulations! You have just made a volcano. And at that point, the North Pole won't be all icy anymore. The polar bears will not be your fans. You will have just made an enormous volcano on the North Pole. But let's pretend that you could keep going, okay? Let's pretend that you just keep going. So you just keep going and going and going, and you dig all the way down. And let's pretend that you could, in fact, still survive as you dug all the way down to the center. Now you know what's going to happen. If you keep going, you're not digging down anymore. You know what you're doing? You are digging up. So now imagine if you were digging up. As you're digging up, you know what's going to happen? All the stuff that you're digging is going to be raining on your head. It's like the opposite of digging a hole. Have you ever dug up before? That's got to be really hard. And all this like stuff that you're digging is raining on your head. It's going to be terrible because you're going to dig your way up all the way to the South Pole. And that's hard enough. I don't think this would work. So somehow my answer to your question is I'm not really sure you would be that successful digging from the North Pole all the way to the South Pole. You will either get blown up by the volcano first, or as you pass the center of the Earth, you will start digging up, and there will be stuff raining on your head as you're going. So please do not try this at home. More questions. I see that somebody is asking me about autobiographical numbers. That's Susan Xu. What's the fastest way to find autobiographical numbers? The issue is, I remember so I want to answer this question because I don't know the answer. I want to try answering it. I might not answer it for you. But I forgot the definition. And you previously had shared in the chat an autobiographical number is something. So please share that again. My moderation team will try to catch that for you. Bring that up for me, and then we'll see what I can think about this. But it could be that I will, in the end, still not be able to answer your question. Could be challenging. Okay. Aha. Oh. I see that somebody said, in order to accomplish that, you would need haste 9 trillion, heat res 9 trillion, and fire res 9 trillion. That must be like heat resistance and fire resistance. Oh, you guys are great. So this is actually what you do in Minecraft, I guess. You guys are great. I like this. I'm trying to find some questions that, might have some mathematics inside them. Meanwhile, I saw that somebody asked, how many sides does a circle have? That's a deep question. Some people can say a circle is sort of like an n-sided polygon where n goes to infinity. And in fact, that's one way that people once went finding. They were curious how you could find things like the area of a circle or the volume of a circle. No, area of a circle or maybe perimeter of a circle or something. It's just that as you go and take more sides, of course, that object that you get becomes closer to a circle. So as you can see, I tried to draw an octagon here. And the general principle is that as you get more sides, it's going to become closer and closer to a circle. That's a very useful approximation. But would we say that the circle has infinitely many sides? I wouldn't say that. I would just say that a circle is what happens when you take a polygon and have more and more sides. Exactly. Because I think it's Ella Wang has said, a circle doesn't really have sides, right? It just has a circumference. And indeed, that's just a name. It's like, what would we call these things? I'm not sure I want to call it a side, right? As far as a circle is concerned, a circle is just something which seems to have one smooth, continuous loop all the way around. Okay. What else do we have? Oh, wow. Okay, let's play with this. I have no idea what the answer is. So what you're saying is you're going to put down some numbers. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Wait, maybe I do know. Oh, this is hard. What you're saying is you can put in between these. Not you can, you must. You must put plus signs or times signs. Okay? Between all of these. All of these you either put times signs or plus signs. Okay? And the question is, if you put plus signs and times signs inside this, what is the smallest value that you can get? Yeah, smallest. We don't have to say minimum positive. It's just what's the smallest value? What is the smallest value if you put plus and times. That's kind of neat. What should we do here? Okay, let's erase everything. What do you think? Well, we do have something called the order of operations, right? The order of operations says that we will always do times before we do plus. Okay, and we don't put any parentheses. We want to make it small. Why in the world would you ever times? Let's just add them all up. You would never times, right? Because if you times, you generally get big. Who wants to do 8 times 7? Do 8 plus 7. So it looks like that must be the answer. Is that what we do? Ah, it's a trick question. It's a trick question because don't do a 1 plus. Why would you do 1 plus? 1 plus is just going to make you add 1. Always multiply by 1. So if I switch that to a 1 times, is that the best? Well, let's just go and think. It's like, would I gain anything by changing the 2 plus 3 into a 2 times 3? No. I mean, if I change it to a 2 times 3, that would become 6. The only thing I could potentially gain is like, well, maybe if I do the times, there's some order of operations, but that's not going to help. I mean, in some sense, anything here that you convert from a plus to a times, it's just going to get your thing to be bigger. Do I believe that? I think I believe that. I'm looking at the beginning. It's like, why would I ever do 1 plus? Whatever I had, if I put a 1 in front, like you'd calculate all of this stuff, and yeah, you'd always get more by doing a 1 plus. So it should be 1 times. And if it's a 1 times 2, then here I don't think I want a 2 times 3, because 2 plus 3 is smaller. So I'm okay with this. No, it's 44, not 44. Well, what's the answer? 1 times 2 plus all of this. Here's how I'll tell you the answer as fast as I can. This is equal to 1 plus 2 plus 3 plus up to 9, and then minus a 1. The reason it's minus a 1 is because I didn't do 1 plus 2, I did 1 times 2. And so the 1 times 2 only gives me 2, whereas here I got 3. And the reason I did this is because it's faster this way. I can just say 1 plus up to 9. Well, what's that? It's how many numbers are there? So this is how many times the average. And the average of the numbers from 1 up to 9 is the same as the average of the first one and the last one. 1 plus 9 divided by 2, that's a weird 2, and then minus 1. So that's equal to 9 times 10 over 2, which is 45, minus 1. I agree with you. There were some people here who said the answer was 44. I think that's true. I think the answer is 44. Okay, so that wasn't so bad. At the beginning when I saw this question, I was a little bit scared because whenever you ask these kinds of things, it's like, what if there are lots of different cases that I have to try? Would it even be possible? Okay, so that was fun. Now I have an interesting question I want to ask you. What if we ask the same problem, but we change from plus and times to plus and minus, and we ask for what's the smallest possible value close to 0? What's the smallest possible positive integer? Let's just try that. I'm a little bit curious what the answer is. 1, 2, 3, 4, 5, 6, 7, 8, 9. By the way, we might conclude that we can't do this because it's too complicated. Okay? So, question is, what's the smallest positive integer value? If we write plus and minus. Now, positive integers are numbers that start from 1 and go on. Oh, is it that easy? Can you get 1? Ooh, minus and plus and so on. Let's try it. Oh, this might be one of these fun patterns. Minus, plus, minus, plus, minus, plus, minus, plus. And you're telling me this is nice? Let's try. The way that whenever I see something like this, I look for a pattern. Is there a nice way to handle this? Well, here's what I'll do. The 9 minus 8, that's a 1. This is a 1. The minus 6 plus 7, that's a 1. This one is a 1. This one is a 1. Are you sure this is 1? If I add this together, I get 5. So that's 5. I don't want to do it this way. Are you saying that there's a different way? So this is equal to 5. Do we still buy what people are saying here? Can you actually get to 1? Oh, but yes, if there was a minus 10, would that help? Not really. That'll give you to minus 5. So now I'm a little bit curious. Does this actually work? Ah. So now we have some people who have an idea, which is like plus and minus. Aha, make the 4 a minus. Oh, this is interesting. Now what we're thinking about here is like, let's go and start to mess around with this, right? It's like if I have this thing and I want to drop it down to 1, I need to lose 4. And how can I lose 4? Yeah. So this actually has some hope of making it work. I see that some people already got it. I haven't gotten it yet. I'm slower than you guys. So I'm going to show you how I would go and try to make this into a 1. I would start to perturb stuff. I'm using what's called almost the greedy algorithm. I'm going to say 5, too big. Let's turn some pluses into minuses. You know, if I turned that plus 3 into a minus 3, I'll get myself a minus 1. That's cool. But maybe that's not good enough because I need to turn it back up, and that would be too close anyway. Let's try to do it with the 5. Would that help? If I go and swap the sign on the 5, I get to minus 5. Oh no, this is not so simple. It looks like I have to do a lot of like shifting back and forth. So I see. So let's just go ahead and try. All right, I'm going to go ahead and start shifting back and forth. I'm trying to make it negative, so I'm going to go and mess with the 5. So if I go and change the plus 5 into a minus 5, okay, if I change the plus 5 to a minus 5, what do I do to my answer? Well, it will actually minus 2 5s. The reason it moves by 2 5s is because it was a plus 5 going to a minus 5, and from plus 5 to minus 5, it drops by 2 times 5. Okay? You're saying I should start with a clean slate. We might soon do that because we might get stuck. Okay? So this is equal to minus 5 so far. If I have minus 5, I would say I need to now push it up. If I want to push it up to be something that's nice and positive, I would like to push it up by plus 6. I wish I had a minus 3. That would have been great. But I don't. Fine. I'll do it with the minus 4. Will that be good? No, this is still annoying. Wow, this is really annoying. What else can I do? Why I'm saying I don't want to do it with the minus 4. If I do it with the minus 4, I'll push myself up by 4 plus 4, by double 4. I'll push myself up to plus 3, and then I need to pull myself down by 2. That doesn't work. This is not nice. So I need to push up by something else. How about the 7? Let's just try, sorry, pushing up means changing a minus to a plus. Let's play with the minus 6, okay? If we change the minus 6 up, what happens? I'm soon going to ask you guys to help. If I change the minus 6 to a plus 6, then what I get is, this is not true anymore, but then I get minus 5 plus 2 times 6. 2 times 6 is 12, which is, 12 minus 5 is 7. And if I have 7, then I say, okay, this will work. This will work. I can make the 7 into a 1. The way I make the 7 into a 1 is I go and say, see that plus 3? Let's change that to a minus 3. If you change the plus 3 to a minus 3, then I will drop down my 7 by 2 times 3, right? So then it won't be this anymore. It will be 7 minus 2 times 3, which is 1. I actually just wanted to show you how when you go and do this kind of a problem, you can actually figure out the answer by saying, I've got something so far, now how do I just change those signs around? I'll try changing minuses to pluses and pluses to minuses. And as I do that, I'll keep shifting my answer around, and hopefully eventually it'll settle onto 1. By the way, let's do a quick double check. Is this even true? 1 minus 2, that's negative 1. Minus 3 is negative 4, I think. Minus 4 is negative 8 so far. Minus 5 is negative 13. Hooray! Plus 6 and 7, now it's 0. Yes! Minus 8 plus 9. It's 1! It works! Okay. So that's how I would try to do this question, but I see that there were some really clever people here who got 1 right away, which is really nice. Oh, I see that somebody put a negative sign in front of the 1. I don't think that was actually allowed. I think you were only able to put things in between, but still, you can be creative. All right. What can we do next? I should take a drink of water, and let's go and find out what question to do next. Anna Howe says there are multiple solutions. That's right. Actually, the reason I had the confidence to do this is because I saw that people in the chat were putting their own solutions and they were all different. So what I said is, look, if there are that many solutions, I'm sure I can just walk to an answer by starting with what I have and just adjusting, add, subtract until it works. And actually the real reason why I didn't copy down your answers is because they were flying by the chat so fast I couldn't stare at them long enough to get your pattern. So what I thought is the faster way to do this would just be to mess around with the numbers. Okay, more questions. Oh, neat. Somebody asked, an angle is 45 degrees. 45 degrees. Maybe I should make this more flat. We have a 45-degree angle. And then you look on a microscope and you blow it up. What do you see? What does the angle become? If you zoom in on the part, if you just kind of zoom in right here, and you zoom in, what angle do you see? Actually, it's still 45 degrees. That's why angles are interesting. So the neat thing about this is that an angle, if you just zoom in and zoom in and zoom in, it's still going to be 45 degrees. Now, why is this relevant? I like this question because you might ask, that's a really dumb question. Why would anyone ask something like that? Well, it's not a dumb question. Actually, when you zoom in, sometimes there's something that changes. And here's the best example. Suppose that you are on the Earth. I see that some people previously were talking in this chat about how, the Earth is flat or not or whatever. So suppose you have the Earth. And if you have this Earth here, you could imagine that on this Earth, you decided to draw some straight lines that go from one point to the other. Maybe you're over here. What's the straight line that takes you over to here? Actually, looks like this. You might say that looks like a curve, but that's because it's on the surface of the Earth. Okay? Now over here, suppose I have another point and I'm going along the surface of the Earth, it looks like this. So from far away, it looks like these are curved. But if you go and start to zoom, Carbon News says, that's vandalism to draw on Earth. Good point. Good thing that this is just a depiction of Earth. But now suppose that you were here and you start to zoom in with a microscope right there. Like over here, when I look at the whole Earth, I see, it's like curved, everything's curved. But when you zoom in close enough on the Earth, that curved surface ends up looking pretty flat. And in fact, as you zoom in more and more and more, it's basically flat. And actually, then it looks sort of like this. So the issue is that when you zoom in and it happens to be a flat thing anyway, then nothing changes. It's still a 45-degree angle. But when you zoom in on something that was a curved surface before, if it's a certain kind of a surface, a certain very smooth surface, then as you zoom in more and more, it looks like it becomes flat right where you zoomed into. And then you can even talk about the angles. And that's actually what the angle between two curves on the surface of the Earth is. The way you define the angle is you zoom all the way in until it looks almost flat, and then you measure the angle. Something like that. Okay, more questions. Prove 9 plus 10 minus 21. Or equals 21? I'm not really sure what that is. 9 plus 10 equals 21? Really? You must be asking some kind of a strange trick question. I'm not sure I understand your question. Okay. Somebody said Novid is making audible noises. Is this supposed to happen? I'm curious, are you using an iPhone? We actually had a bug that we thought we fixed in one of the recent versions. If you have any weird things about the Novid app, please press the email us. There's some button inside the app where you can press the email us and then please tell us what's going on. And when you do that, that will also tell us what version of the app you're running. And we hopefully will be able to help remove that bug. Okay. Oh, someone said in Roman numerals, 9 plus 10 is 21. Oh, that's cute. Okay, I understand. Very clever. What you said is 9 plus 10 is equal to 21. By the way, let me say something about Roman numerals. With Roman numerals, does anyone know how you would express a number? So here's a question. What is Roman numerals for the number, let's just say 1994? Not so much fun. I mean, it's possible you could do that. It's like if you wanted to do this, it's going to be like M and then CM. That's the 1900. And then the 94. Oh my gosh, what is this? Is it XC? And then IV. Oh, somebody else wrote that down. Alan Liu. So it's this. This is horrible. I mean, if you want to write down something like this, imagine how you do addition. You know, like if I wanted to do 1994 plus 37, if I want to do that. Oh, let's just make life harder. Plus 40, 47. Okay? If you wanted to do 1994 plus 47, here's what you do. Plus, what's 47? X, L, X, L, V, I. Who wants to do this? It just doesn't work. Do you know what I mean? It's like, excuse me, but what am I supposed to do here? You don't go like V plus I is something, I plus I is something. It's just a complete disaster. You can't actually do proper addition with Roman numerals. And what if we ask something worse? You know what I'm about to do? Huh? You know, like, what are you going to do here? Are you going to go and try to multiply these two numbers? It just wouldn't work. And this might be one reason why we don't use, not that this might be, this is actually why we don't use Roman numerals. They're not very efficient. It's like, good luck doing any kind of arithmetic with Roman numerals. Oh yes, even John asked, what if you asked division? I'm not even going to bother writing that down. But, you know, like if you asked for division, it's like, okay, this doesn't make any sense. But you understand my point. It's like you wouldn't want to go and put this thing over there and try to do some division. Okay, right. So that's why we don't use Roman numerals. And by the way, does anyone know how to say 10,000 in Roman numerals? I'm a little bit curious about that too. Roman for 10,000. Oh, there is something. Ian Ray, you're good. You said it's X with a line over it. Apparently the 1,000 is like, you know, it's like 10. Oh, I see. Temp ID is hungry. Yes, you can put these lines on top. So in fact, the lines appear to be how you get it. That's pretty good. But as you can see, people at some point realize that this is just not very efficient. Okay, let's keep going. More questions. Oh, neat. The real paperboy has asked, can any two decimals multiply to make a whole number? And by this, I think you mean numbers that legitimately have decimals after them. Can you make, you know, like some number point some number times some number point some number, and somehow that's equal to some number point 0. That seems like a very interesting, legitimate question. It's like, doesn't seem like it. You know, like if you try to multiply, won't all of those decimals like multiply and get even worse? Well, you know, the way math is, it's sometimes that there are sometimes that you can get weird stuff to combine and it becomes nice. So at first it might look like when you're doing the multiplication, it's like, come on, if I'm going to do this multiplication times multiplication, you know, you'll get stuff, and then you'll get stuff, and then you just move the decimal point over and put it here. But if those are all 0 at the end, it could be good. And I can see that in our chat. Some people have already found that, you know, there's some pretty nice ways to do this. In fact, one of the nicest, simplest ways to do this, there are a lot. And in fact, reciprocals are a nice way to do this. By the way, this is a really wonderful question. Thank you for asking me, because it's a very counterintuitive problem. For example, if I take 2/3 times 3/2, if I went to write these, each of these would be a decimal, right? But when you multiply them, actually, it's just 1. So that's nice. If you complain and you say, oh, but come on, this particular decimal goes on forever. What if you wanted a decimal that stops? If you want a decimal that stops, what you need to do is not have a 3 in the bottom, but like a 5. That would work. If instead you did 2/5 times 5/2, well, that's also equal to 1, but that's 0.4 times 2.5? So the answer is, in fact, yes. And thank you very much for asking that question. Okay, more questions. What else do we have? Oh, I see. Kirito Hei asks, what's the name of that physics book that my parents bought for me when I was young? So there's a great physics book. I'm happy to recommend this physics book. This physics book is called The Cartoon Guide to Physics. Strongly recommended. So this is a great book recommendation. It happens to be, it's all a cartoon. And I read it when I was maybe in 5th grade, 6th grade, or 7th grade, something like that. Ooh, some people here said, I read that book, I have that. And somebody's asking, seems kid-friendly. It's totally kid-friendly. Where can you get that book? From the bookstore. I guess the bookstore is called Amazon or something. The author is called Larry Gonick. It's really quite engaging. It's a great book. And just through the pictures, it kind of walks you through all kinds of things, whether it's the physics of like space, or the physics of cars, or the physics of electricity and magnetism. I think it does a great job. And whether or not you know physics officially, it actually is a great way to get to know a lot of the concepts without having to take like a very deep high school class. And eventually when I took the high school physics, because I had understood that book, it was a lot easier. Okay. Is this some sort of ad now? Carbon News, I actually have no connection whatsoever to the book. This is not an advertisement for the book. It's just that people asked, it's like, what was that book that I had mentioned that I found very useful before? Okay, more questions. Oh, neat. It's another question about, it's a number puzzle. Let's go and try this. Again, I don't know the answer, but maybe you'll help me. So this is from Cool Kid. And Cool Kid says, we have some positive integers. These are all positive integers. You're supposed to find the positive integers. And these positive integers say a plus c times b is equal to 24. Also, b is even. What else do we know? We also know that b divided by a is equal to 0.8. Okay, now we need to know what are a, b, and c. Well, if I look at this, I see that we have some stuff which is positive integers making 24. Whenever that happens, then you know they're not going to be very big, because I can't use fractions, I can't use negative integers. So if I'm going to be able to make 24 somehow, then I need to find an easy way to make b divided by a to be 0.8. The first thing I would try is 0.8 is 4/5. That's like the smallest fraction I can make. And I'm wondering if 4/5 would be useful. 4 divided by 5. I don't want to go to the next thing, which is 8/10. If I use 8/10, then I'm worried that I'll have too big of numbers here and I won't be able to multiply to 24. Does this work? So if b is 4, that's even. If a is 5, that's okay, 4 over 5 is 0.8. I see that some people were suggesting, what if you rewrite b as 2k? You could do that, but I'm trying to say how I might try to do this without even working as hard. By starting with the 0.8. I wanted to start with the 0.8 because that was the one that gave me the most constraints on my numbers. So now if b is 4 and if a is 5, could that possibly work? If b is 4 and a is 5, 4 times 6 is 24. So I think the answer is 5, 1, and 4. And I think this is okay. Yes. I see that somebody said, are those all the constraints? Doesn't seem very hard. Well, you never know. The only way you can know is you write everything down and you try it. And this looks like this is what is right. Okay. Oh, and somebody says this is correct. Good. More questions. Alan Tang Alan Tang has asked, how many times would everyone in the world have to spam E in this chat in order to disable YouTube? Wow, if you want to disable YouTube, that's going to be pretty hard because the servers that everyone is connecting to are all different servers that YouTube manages. There's not even just one YouTube. There's like YouTube has all these different servers that everyone in this chat is quite possibly connecting through different pathways on the internet towards YouTube. And so if you actually need to spam all of those, I would expect that there are too many servers for all the human beings in this world to completely spam. And here's why I say so. It's because somehow a reality of this life that we live in is that a lot of people are always watching YouTube. So I wouldn't be surprised if the fraction of people who are watching YouTube at any given time and possibly leaving comments is, like at least 1 in 10,000, that's for sure. And maybe even 1 in 1,000. But there are certain times in the world when everyone's watching at once. For example, in the United States, that's the Super Bowl. And you'll find like tens of millions of Americans are all watching it at the same time. By the way, that's a fraction which is like almost like 1 in 5, 1 in 6. And if YouTube can handle that kind of traffic without any trouble, you can like multiply it by another 6 and it would still have no trouble. I'm just showing you how I would think about these kinds of questions. And even though you may have thought it was a silly question, it's a real question because it's the kind of things that we think about. We're building Novit. We're building an app that people can use to track the spread of COVID-19. And so we have to think about, what happens in the worst case if suddenly everyone in the world is using it? Will our computers crash? And so the answer is computers are very powerful nowadays. And you wouldn't be able to actually do too much if you just spammed E. Other than maybe annoy people, I think that's what you would be achieving, but you wouldn't necessarily crash YouTube. Okay. Huh. Oh, this one looks cute too. Let's try this. So this is a question from Ella Wang. Ella Wang is asking, it's Leon Ella Wang, and Ella Wang has asked, if I have a squared b is equal to 30, if I have b squared c is equal to 40, and if I have c squared a is equal to 45, what are a, b, and c? That's the question. Okay, if you look at this question, you could say, I could possibly even factor this because all of these things are, all of these numbers are numbers that I could factorize, and maybe I could even figure it out. I mean, it looks like it might be possible. But it turns out that with these kinds of problems, it's one thing you can do is to try to do that kind of like factoring and try to solve it. But another thing you can try to do is you can often try to combine things together. Avon John says multiply. Let's multiply everything together. The reason why this is so powerful is if I multiply all of them together, you know how many a's I get? I get a squared and I get another a. So that's a cubed. You know how many b's I get? Well, I have a b squared and a b, so there's 3 b's. How many c's do I get? C squared and a c, so there's 3 c's. Now, I don't actually want to multiply those. I want to prime factorize, okay? So the 30 is 6 times 5. Well, let's prime factorize them first. 2 times 3 times 5. 40 is 8 times 5. 2 cubed times 5. 45 is 9 times 5. 3 squared times 5. Okay, so when I take all of this and put together, what do I get? I get 2 to the power 4. Okay, 2 to the power 4 times 3 cubed times 5 cubed. So now I can tell you what a times b times c is, and people are already unhappy. It's not a perfect cube. That means that doing the prime factorizing this and trying to guess and check would have been a disaster. And the reason I didn't do that is because when I was doing that in my head, I saw that I have a squared b is 30. And then I got a little bit worried because if I have a square times something to be 30, 30 has no squares in it. 30 is 2 times 3 times 5. If I want a square in it, it would only be 1 squared times 30. And if b is 30, it'll be a disaster. So let's try. That means that ABC is equal to the cube root of this thing. That looks like it would be the cube root of 2. Ooh, trick question. Times 2 times 3 times 5. Because what I just did here is I said this is 2 times 3 times 5 all cubed. So if that's a, b, c, now do I have any way of getting a, b, and c back? What could I do here? I guess I could try to do some random divisions. When in doubt, do random divisions and see what happens. Or is this not enough information? We'll find out soon, okay? So, neat question. Okay, somebody's asking, where did I get the 2 from? Okay, so let's look at this slowly. This was 2 to the 4th times 3 cubed times 5 cubed. And so that was 2 times 3 times 5, whole thing cubed, right? And the reason why that's true is because there's like 3 2's and another 2, 3 3's and 3 5's. So then we got this. And then so I can go and divide, and I can get a, b, c. Sorry, not divide. I can cube root. When I cube root, I get the cube root of 2 times the rest of the thing. Okay? So now I know what ABC is. It's some strange thing. Somebody said ABC equals 60. I'm not sure that's the case, because actually over here, I don't think we made a mistake. We just multiplied everything and we tried to take the cube root. So, okay, when in doubt, what do? We start messing with the equations. So if a times b times c is this much, is there a simpler equation I could make? Let's go back up to the a squared b. Maybe I can try to turn the a squared b into something that's not as annoying. Like squared is kind of annoying. What could I do there? Actually, as I'm looking at this, I'm like, that doesn't look good either. Is there something else I can do? Oh, there's something else I can do, okay? So I'm looking at this and trying to think if there's a clever way I can try to solve this problem. I'm going to start by multiplying the top 2 equations together. If I multiply these 2 together, I'll tell you why I'm going to do it. I'm going to do it because I want to kind of get other weird things I can make with different numbers of a's, b's, and c's, and then I'm going to divide through by this thing whenever I want to. Okay? So if I go and multiply those 2 together, I get a squared times b cubed times c to the first is equal to 30 times 40. Okay? I guess I can write 30 times 40 here, but normally I would actually do it with the prime factorization. But if I look at what I have here, I have that ABC is equal to 2 times 3 times 5 is 30 times the cube root of 2. So if that's the case, let's divide this by the ABC. And if you divide this by the ABC, we start combining this, and what you get is, what do you get? Let's see. Divide by ABC, I would get a b squared is equal to, and now I divided it by ABC, so I get 40 divided by the cube root of 2. I can simplify that by rationalizing the denominator. Maybe I'll do that later. But I just want to say, so far I got ab squared. Now, does anyone know why I got excited to get ab squared? Why is it a good deal if I can get ab squared? There's a reason why, as I was doing this in my head, I was like, oh, if I multiply these 2 things, I'm going to get a squared b cubed c. Then I divide through by this, and I get ab squared. And why is ab squared good? In light of what I have, if I already have a squared b, and I also have ab squared, I'll be able to use the a squared b and the ab squared together to go and figure out what is a and what is b and maybe what is c. Okay? So now, here's how I'm going to do it. I'm actually going to go and take this equation and multiply it by this equation, and that's going to give me a cubed b cubed. I'm going to do that because once I know a cubed b cubed, then I'll figure out ab, and then I'll figure out what is c by dividing. This may or may not be the most efficient way, but it'll work. So let's start multiplying. So I'm going to go and take, well, this question was pretty challenging. I'll go and take this one, ab squared. I'll take this one. Actually, let's circle all the way around. We're going to just multiply those 2 together, and that's going to give me a cubed b cubed. So now, these 2 combine, and I'll get a cubed b cubed is equal to, it looks like I have the 30 times the 40. Okay, if I put all that together, how much is, let's put the actual powers now. 30 times the 40. So the 30 was, oh yeah, they're right here. This was the 30, this was the 40. If I multiply them together, I add the exponents. So that's going to give me 2 to the power 4 times 3 times 5 squared. Okay? And don't forget to divide by cube root of 2. Wow, what a weird question. Okay? So if I have this, now I actually also want to think about everything in terms of powers of the 2s, 3s, and 5s. We're going to use some fractional exponents in a second. So if that's a cubed, b cubed, this is equal to 2 to the power 4 minus a third. What's that? 11 over 3? 3 and 5 squared. Who made up this question? This question is nuts. Okay, so please let me know if I made a mistake, because it's very possible that mistakes happen. But if that's a cubed, b cubed, now I can figure out what ab is. Just just cube root. If I cube root, then finally ab is equal to 2 to the power 11 over 9 times 3 to the power 1/3 times 5 to the power 2/3. This is called bashing the problem. Okay, so now I got AB. If that's AB, how do I figure out C? Actually, now I can figure it out, because over here, if ABC is this thing, I can figure out C by just taking the ABC and dividing by the AB, right? So then this will work. I just take this ABC divided by the AB, and after I do a division, I just get C is equal to whatever happens when I do this division. And over here, if I look at these powers, this is 2 to the power 4/3, right? Because it's 1 and 1/3. 4/3 minus that. What's 4/3 minus 11/9? I need some scratch work. Over here, I'll do 4/3 minus 11 over 9 is equal to, 1/9. Really? Did I make a mistake? Let me know if I made a mistake. But it seems like it's reasonable. Okay? Yes, somebody is saying that this question is a little bit annoying. It is a little bit annoying because somehow the answers... Oh, yes. I see somebody asked, how did a cubed, b cubed come? It's because I had an ab squared and I had an a squared b. And if you multiply ab squared by a squared b, then you get a cubed, b cubed. That was the whole point. Oh, there's a mistake. Where's the mistake? If somebody sees a mistake, please tell me, because a mistake is quite possibly likely to happen inside this kind of a problem. But, if there's a mistake, we'll also see it pop up into the moderator's queue as people type it in. But what I have here is 2 to the power 11 over 3, right? That's 4 minus a third, right? That's 12/3 minus 1/3 is 11 over 3. Good, that becomes 11 over 9. And then over here I have 4/3 minus 11/9, right? Okay, 4/3 minus 11/9 is 12/9 minus 11/9, 1/9. So this is equal to 2 to the power 1/9. C will be 3 to the 1 minus 3 to the power 1/3, 3 to the power 2/3, and 5 to the power 1 minus 5 to the power 2/3, 5 to the power 1/3. So I think we actually have a value of C right here. So after you divide, you get C. And so C is this nonsense. And then what would you do to figure out all of the rest of the things? I'm going to say, if you have C, you can figure out everything else. How a cubed, b cubed is wrong? Some people are saying a cubed, b cubed is wrong. I'm not entirely sure. I think that what I'll say is, if there is an arithmetic mistake, that's not the main point, right? Let's just go and finish, and we're not actually going to go bother finding the exact answers, because in fact the most important thing is just to go and say like how you would solve a question like this, and you see how horribly ugly C is. Once you got C, you can get B. How do you get B? Once you get C, you can get A. So you just like square it and then just divide, and you get an A. And if you want to get B, if you had A, you can go use this to get B. So I'll say that somehow, if you just do this, you'll be able to get A, B, and C out of it. The question asks, is there a slick solution? There is, I think, a way to think of a slick... how is there not a slick solution is a question. In fact, what I was just doing is I was just doing something related to linear algebra. This is sort of like something to do with matrices, okay? So what's actually going on here is, if you think about logarithms, what's really happening here is 2 times the log of A plus the log of B equals 30. So actually what's going on here is that I have I'm actually solving something like this. 2, 1, 0, 2, 1, 0, 2, 1, 0, matrix. Log A, log B, log C is equal to 30, 40, 45. Yes, that's the same problem. So actually that's what we're doing. And so if you want the slick way to do this, you actually need to invert this matrix. So in fact, what's really going on is you're taking the inverse of this matrix multiplied by that vector and then taking the exponent of everything. And now this matrices is definitely not appropriate here. Well, in this audience, when we were talking about pre-algebra, yes, matrices is not appropriate here, which is why you never saw it. We're back here. But actually, what we just did, what I was just doing here is something called Gaussian elimination without the matrix. Because that's why what I did is I went and first kind of combined stuff and I said, oh, hang on a second. I want to get something that just has powers of A and B. And I got two different things with different powers of A and B. Once I got that, I was like, okay, now we can go and solve for these A's and B's. Actually, it's not true I was using Gaussian elimination. That's not true at all. But what I was doing is I was basically solving a system of equations with 3 equations. All right. Well, that actually puts us over time. So unfortunately, today we don't actually have time to discuss further fun mathematics. If you're asking about the slick solution, you saw it for a flash on the next screen, which was something about inverting matrices. I'll finish with the last question. Are you a robot? I don't think so. Am I? I have a side too. So yeah, no, I don't think I'm a robot. Things are good. But I thank you all for coming today to join this particular Ask Math Anything. We'll be back tomorrow. Tomorrow is the usual time, 4 o'clock to 5 o'clock p.m. Eastern Time in the United States of America. Until then, have a great day.